Hello everyone. Today we're going to be going over the 30s. There's a note on this very first slide that lets you know that Arrhenius acids have hydrogens out in the front, so it's a very easy way of identifying if something is an acid. And bases have the hydroxides at the end, so it's a very easy way to identify bases. This is the one that seems to confuse most people, and that's acetic acid. Problems A through G, I wish for you to pause this right now and go ahead and give them all a try. That way you'll learn the most. If you just watch me go through them, you're not going to learn really much of anything. So here we go. A, formula for sodium hydroxide, NaOH. Circle the word or words that describe 0.1 mole per liter or molar sodium hydroxide. You may need to go back to the cover of your unit pack for some of these words. First of all, we said anything that is less than 1 molar is considered dilute. Monobasic means it's got one hydroxide in the molecule, so this is monobasic. And is this a strong or a weak base? This is a strong base. Again, those three things are covered on the cover of your unit pack. Write the dissociation reaction for sodium hydroxide. So NaOH, solid, and that's going to break apart into Na1 positive ions. And that's going to be aqueous. It's not going to break apart unless you throw it in water. And then you get hydroxide ions. And again, aqueous. Dissolved in water. That is the dissociation. Write the formula for sulfuric acid. Hopefully you'll start to learn this as time goes on, but if not, it is on your cover. H2SO4. Circle the word or words that best describe 0.3 molar sulfuric acid. Well, its molarity is less than 1, so it is dilute. Sulfuric acid has 2 hydrogen ions in it, so this is called diprotic. And it is one of the strong acids on the strong acid list. Write the dissociation reaction for sulfuric acid. So H2SO4, this comes as a liquid. You would know that, and that's okay. Here you get 2 hydrogen ions, aqueous, and you get a sulfate ion. So these 2 hydrogen ions come into play in one of our very first problems. G, write the net ionic reaction for neutralization of an acid and a base. This is what we use to represent an acid. Aqueous. Plus what we use to represent a base in most instances. Aqueous. And when the two come together, we call that a neutralization, and they make liquid water. This is on your cover. You will need your cover for solving the problems. These are the longest problems that we have encountered so far. So on your cover, we can see that we can go from liters of an acid to the moles. You might want to write that on there, of an acid. Then we have to go to moles of hydrogen ion, to moles of hydroxide ion. This right here is our neutralization step. Then we can go to moles of any base, and then we can go to liters of that base. So we're going to be using this a lot. You'll need to kind of figure things out before you even start a problem. So in our very first problem, we will be using this map. So it says, how many milliliters of 0.1 molar sodium hydroxide will it take to titrate or neutralize 22.0 milliliters of 0.33 molar sulfuric acid? So this is a little bit of mental work that you would need to do for this problem. We're going to need to know that there's one hydroxide in a sodium hydroxide. We're going to need to know that there's two hydrogen ions in one sulfuric acid, and that this is what neutralization actually is. So again, look at your map. There is a note in here. Don't start with what you're trying to solve for. So in this problem, we want to know milliliters of sodium hydroxide. So don't start your problem with sodium hydroxide. Start it with the other item. The other item in this problem is 22.0 milliliters of 0.33 molar sulfuric acid. That gives us a lot of information, and that's what we will start with. So if we look back on our map, so we are going to be starting with milliliters, which we'll then have to convert to liters, which then will convert to moles of acid, then to moles of hydrogen ion, then to moles of hydroxide ion, then to moles of base, then to liters of base, and then finally to milliliters of base. So this is a fairly long problem. Kind of watch this as we go through the steps. So I'm going to erase everything that I have up here so we don't distract. And we will solve this problem. So again, we start with the information that they give us. We don't start with what we're trying to find out. We're trying to find out about sodium hydroxide, so we don't start with sodium hydroxide. We start with the sulfuric acid. So this problem gives us 22.0 milliliters of H2SO4. I apologize for how I have to write on this, but that's how it goes. So if milliliters of H2SO4 are on top here, milliliters of H2SO4 have to go down here. I can convert milliliters of H2SO4 into liters of H2SO4 if I look on the map. So again, liters of H2SO4. I'm going to change colors so maybe it's a little bit easier to follow. If liters of H2SO4 are up here, they have to go down here. So liters H2SO4. If I look at my map, if I'm on liter island, the only place I can go to is mole island. So I'm going to go to moles of H2SO4. Don't worry, folks. On the next slide, I give you a very nice and pretty typed up version of this. If I'm on mole island, which I am right here, I have to go from moles of H2SO4 to moles of H2SO4 right down here. Mole island, the only place I can go is back to liter island. I go to atom island, I go to gram island, but that's not where I want to go at all. So for moles of H2SO4, I go to moles, whoa, that really looked ugly. Let's try that again. I go to moles of hydrogen ion. Apologize for the board, folks. It's giving me a little bit of difficulties. Moles of hydrogen ion. Moles of hydrogen ion are up on top, so moles of hydrogen ion have to go down here. From moles of hydrogen ion, the only place I can go is to moles of hydroxide island. Whatever I have on top must go on the bottom, so moles of hydroxide ion go down here. From that island, the only place I can go to is to moles of base. So the base I have in this problem is sodium hydroxide. So NaOH. Whatever is on top must go on the bottom of the next step. So moles of NaOH go on the bottom. For moles of sodium hydroxide island, the only place I can go to is to liters island, so it's liters of sodium hydroxide. Whatever's on top goes on the bottom of the next step, liters of NaOH, and I can go to milliliters of NaOH. That's what I want my answer in. So now I got to put some numbers in. I'm going to go all the way back to the beginning of liters over milliliters. The relationship is 1,000 milliliters to 1 liter. Moles over liters, that's molarity. And the molarity of our sulfuric acid is right here. So 0.33 moles in 1 liter of sulfuric acid. When I go from moles of sulfuric acid to moles of hydrogen ion, there are 2 moles of hydrogen ion in every 1 mole of sulfuric acid. Really make sure you understand that step. This next step is called our neutralization step. This is where we go for every 1 hydrogen ion, there is 1 hydroxide ion. It's called the neutralization step, and we're always going to circle that step. Make sure that we have it. It's going to be in all of our neutralization problems. The next step is moles of hydroxide ion in sodium hydroxide. Well, there's 1 OH in every 1 mole of NaOH. So 1 mole of hydroxide ion in every 1 mole of sodium hydroxide. The next step is liters over moles, which is molarity. They give us that in the problem. It is 0.180 moles. So 0.180 moles. I apologize, folks. The board's really funky there. 0.180 moles of sodium hydroxide in 1 liter of sodium hydroxide. And again, 1,000 milliliters in 1 liter. I do all of that math, and I get 80.66 milliliters of NaOH. Sig fig wise, I look through all of those numbers, and right here I have a 0.33, which means I can only have 2 sig figs, so the answer is 81 milliliters. So there is a pretty version of everything that I just went over. Those are all the steps. Follow the map. Make sure you understand how the map works. You have to follow that map to solve these problems. This step right here, we will always circle. It's called our neutralization step. Even though mathematically it does nothing different, it needs to be there so you can go from the acid world over to the base world and keep the problem going. So it's a bridge to get to where you need to go. The rest of this sheet is your homework. Good luck.